Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 8, Lesson 2, on circles. Now, I don't know who might be watching this video, because since this just says circles, don't go on here if you're trying to see things for like geometry and stuff. This is algebra lessons, and this will show you what the equations are like for circles and how to graph them by hand, also in the calculator, and then also what you can tell just by looking at an equation. So, the common form that you see for circles is you have x plus or minus h squared plus y plus or minus k squared equals r squared. Also, if you want to have the r not squared, obviously what you could do is take the square root of both sides, and that would make it just r, but you still have the square root left on one side. So those are the two common forms, which are really the same thing above. But sometimes you need to set it equal to y, and that's what you have to do to graph it in a TI-84 usually, because, any calculator I've seen, that's what you push the y equals button, and I'll show you how to do that later in this video. How you can convert to the form, it's simpler than it might seem, because that looks like something really dumb, like what the heck, r plus h minus k, or just all those things. So I don't like that they use h and k for the coordinates of things like in algebra, like with formulas that we've seen, because I accidentally sometimes say the wrong thing, because I don't know why, I for some reason accidentally say the wrong one. I know they're not the same letter. I know my letters, obviously, but that's just, for some reason, that's something that I do on accident with h and k. So, let's see. There's not really names that you call these forms, like with quadratics, where we had, like, vertex, standard, factor. I just like to call one the usual one, and then the other one the y equals one. Sometimes they call it the standard one for this one. But I think that's kind of dumb, because it really would seem as if it's factored. But whatever. Okay, so here's what the variables mean. So we see, what do we see? What letters do we see? We see H, K, R. We obviously see X and Y, but we know those aren't really, those are just the values that you can have, like for coordinates. You know that, so H and K, usually that means transformations, and it still does. It just means transformations for, like, the center, not necessarily, like, all, I guess it does mean for all points, but really, if you want to see a parent function for a circle, it really would just be as if all those things were, well, R was, I guess everything would be 1, technically. There's not exactly a parent function for this, but if you wanted one, it could be somewhat like this. We need to have this. Technically you could have 0. Yeah, that would actually be if the point was, if that was at 1, 1. This isn't something you really have to know, but that would kind of be what it's like, if that's the parent function. But this is just a thing that can show you if there's transformation. So H and K as usual, can't even talk. That usually means, like we've had, that's the coordinates of, that's the center. So, but usually, remember, we have, the H value is always opposite of what it is. But this time, since K is on the same side as Y, that's the case for K too. So whatever number you see where h and k are, you need to make it negative, or if it already is negative, make it positive, and that will tell you the coordinates. So the coordinates of the circle would really just be negative h, negative k. And r is the radius. So remember, radius is the like distance from the center of the circle to the outside of it. Not all the way across, that's diameter. So the radius will never be negative, because that's just not a possible thing. So let's see. Let's practice identifying circle features. So it says for 1 through 2, name the coordinates and the radius. So that's all we need to know. Okay? All we need to look at is what values we see. And so 1 and 2 are in different forms, but we can see what they would be. So we have a -3 here, -2, and a 36. So let's just start out by identifying h, k, and r. So h, -3, k, 2, r, don't say 36, because remember, the equation up there had it as r squared. So if 36 equals r squared, then to find just r, you take the square root, and then we would see that it would be technically a plus or minus, but remember I said r can never be negative, so just plus. So 6. So that means that if we need to change the values of, change the signs of h and k, that means that our center is 3, -2, and our radius is 6. So pretty simple. Let's look at this next one. Okay, this is in the form where there's the y equals. So that means that we need to things are different a little bit. So let's once again find out what h, k, and r are. So we see this is the k, going back to the formula up there. So that is 4, and you don't need to change the sign this time, so because that is on a different side of y. You see, because y is on that side. So that, for this case, when it's in this form, you don't make the k negative. Then we see that we have a -2 and a +2. Those are the h values, but remember, for this part we said that we have plus h and minus h in the formula. So if this is the plus h, then h is -2. Then r would be our 3 that we see here. That's our radius. So 3 is our radius, and we still need to change the value of, we need to change the sign of the h to 2 because it is on the same side as the x. Alright, so that's what that is. Alright, practice converting to the y form. Example, okay, this is something I worked out just to show you how I did it. Alright. Sorry. So we see, oh, this is actually the equation we already had that we looked at. So I have yellow, blue, and pink, and you can see this is the original form. Now, usually, I don't know what your teacher would be like. This isn't technically even a standard to convert to the y equals form, but I would suggest that you know it, because sometimes it might be helpful to graph things in a graphing calculator, just in case, since you have access to that during exams, typically. So, you wouldn't really need to convert back to this form. That's what I think. So here's the original form that you'll see, and we found out that this would be our h, this would be our k, and this would be our r, the 6 would be our r, because remember we already said you need to take this square root, because r squared is what's over here, so just to find r, you take the square root of whatever's there. Then we see here's our equation for the y equals 1, and you technically could mathematically isolate the y, but that's just kind of complicated. So really, you can just switch the values. So you put the R values where they go, you put the K values where they go, and then you put the... Wait, I think I might have done something wrong here. Oh yeah, what I did wrong was actually in this problem right here. Sorry. That, I didn't mean to say that. This is actually the negative h right here. So if that's the negative h, then it already is negative. So negative 2. Didn't mean to do that. Sorry. Alright, let's go back up here. Back to what I was saying. So you plug in the values where they need to go. Although this says plus h, that's just saying keep the value the same. The pluses and minuses don't mean that's what you make it in the formula. It means if it's plus, you keep the value the same, and then if it's minus, you change it. Even if it already was minus, you make it plus. So that's why the k stays negative 2. And then we see that the negative 3 went there, and we had to make it... we needed to make it positive right there because of the positive h right here. You need to keep the sign the same because h is not negative 3. H is positive 3, as we see down here. And then k is negative 2. You just have to change the signs of h and k. So that's why if you need to keep it the same, that's why we made it 3 there and we made it negative 3 there. So I know this might seem a little bit confusing and like crazy, but you just need to I'll have the steps in a second. So now let's just see the steps. So you need to first identify R, H, and K. So I guess that example wasn't really helpful there because I didn't tell you how to do it. I don't know why I did that then. Then you need to fill in the spots accordingly, keeping in mind of signs. So I didn't write that here, but this is true. Wherever you see a positive in the equation, you need to make the sign the same. Keep it the same as it was. So if it was a positive, then you make it positive. If it was a negative, you keep it negative. If you see a negative in the equation, then you make it different. So if it was positive, you make it negative. If it was negative, you make it positive. So, and to keep in mind that the equation is this. We have square root over this r plus, I'm not going to say it all, but Alright, and then it's kind of a long thing here. Okay, then we have plus k. Okay, so if we need to first, for this problem, identify R, H, and K, let's do that. R is the easiest. It's just what you see. Oh, there's nothing there. 1. That's what that means. Okay, H. We see here that's plus 1. So if you need to change the sign, then it would make it negative 1. Just to remember why, you're really setting that part equal to 0, and then x would be negative 1. That's the reason why. And same thing with the y. You just would set that y minus 2 equals 0. You would find that y is 2, which means that our k value is positive 2. So you're just really changing the signs of those two things. Then we need to plug into the equation here. Oh, what was I doing? I don't even know what I was doing. R is not 1. I don't know why I did that. I was thinking as if it was already in that form. R is this 25, and you need to take the square root of it because 25 is r squared, and we want to know just r, and that would be 5. Really plus and minus 5, but like I said, there's no negative values for the radius. Okay. Sorry that I sometimes do little things like that. I don't know what I was thinking, why I said that r was 1. Now we just have our values here, and we're gonna I'll just leave some open spaces to where things can go. Yeah, that's just crowding things up too much, so I'll just go ahead and just go for it. So let's put r where it needs to go. So r is 5, r is 5. Then we need to have a plus x on this part and then a minus x on this part. Then we see that we have a negative h. So that means we need to make the sign different from what we found out h was. Since we found out that it was -1, we need to make it +1. Then we have a positive h there, so that means we need to keep the sign the same. So we have a -1 here. And then we have a plus k, so you keep the whatever we found out k to be the same, which was 2, so we'll just put 2 there. So, to rewrite this simpler, this is what we would have as our equation. We see that we started out with this, and you can't type that into the calculator to graph it. You have to type this. So that's a pretty handy skill. So now let's do some didn't do that. Practice graphing. Here's the steps that I have. You need to identify the center and radius. Therefore, you need to once again know what r, h, and k are. Plot the center. So the whatever points of h and k you get, plot that. Then in each direction, this might not make sense written down, but I'll show you what I mean. In each direction from the center point, up, down, left, and right, you plot a r unit. So if r is 1, you go up 1, left 1, right 1, down 1 from the center point. And plot a point, and you connect the 4 outer points to make the circle. So let's graph this point. This equation for a circle. And once again, going back from the last lesson, we know it's a circle because we see that we would have an x squared and a y squared, both positive. Alright. And same coefficient. So, we see that this is 9 here. That's what r squared is. So, taking the square root, we would find that it's 3. Then h, we see that there's a -2 there. We need to change the sign to make that -2. That's +2, make it a -2. Then k, we see that there's a +3, make it a -3. So, our points for our center is -2, -3. So let's plot that point. -2, -3. Now, in each direction, up, down, left, and right, you plot r, which is 3. So, let's go up 3, 1, 2, 3. And then that's 3 to the left. That's 3 down. That's 3 to the right. Alright, now we'll just have to do our best. It's not very easy to draw a circle perfectly, especially when it's on something like this. But that's a close to what that circle would look like. So there you go. That's how you graph a circle. Now, something to keep in mind, think about, is when we had our unit on polynomials. Remember, when you could make a quadratic have a higher exponent that's even. So you have an x squared, it's like that. You have a x to the 4th, it's more like that. It's the same case for a circle. It makes the edges flatter. So if these exponents of 2 happen to be 4, this circle would look more like, well, really what I drew it like, it would be more like, kind of just like a box with rounded edges. Then if you had it like, I don't know, 68 or something, then it would make it like, almost like a square. So that's how you can change that. And then if you were thinking, what if it's odd, then that kind of just makes it like this, something weird. You would just have to test that in the calculator. So that is graphing. I was about to say that's it for this video, but not. One more thing. I want to show you how to put in the calculator. I said that at the beginning. Tap y equals. So that's what we first need to do. I have a calculator app on here so you can actually see. Of course, why do you push the y equals button? They call it that because that's what form you have to type an equation in. So you would have to transform it to the y equals form. since there's no plus or minus button, oh yeah, I think I forgot to say that. Yeah, I did. Down here, we would actually have plus or minus. I forgot to say that. Plus or minus, because if you just had plus, then it would make it only like this. That's the top part. The minus part, it counts for the bottom half. You would see that. Sorry, I forgot to say that. So, since there's no plus or minus button, which is what you technically would need to do after you convert it to the y equals form, you have to put in the y1, like in one line, one of the lines on the y equals, you would do the positive part, and then you would do the negative part on the next one. So graph the above equation, like not by hand, just in the calculator. So let's see, we have this one up here. Sorry, I don't know what just happened to my voice. Just got like something stuck in my throat. So, you have this. Alright, we had... It's weird. It's not... Alright, now... Sorry. We found out that 3, -2, -3. Those were our values. 3, -2, -3. Now putting that into our new equation, we would have y equals square root positive negative. We need to have r3 plus x. Change the sign of the h. I said how to do that earlier. Wait a second. Might have messed something up here. Alright. Didn't mean to do that. No plus. Almost forgot. Okay, so then you pretty much just change the x and h, and we have, well, since k is negative, we keep it negative, -3. So this is the equation we're going to need to be typing in, which, since I'm going to have to go in a different app, I wish I could write that down, but I don't even have anything. I'll take a picture on my phone and then look at it that way. Okay, so, hang on a second. Alright. Now let's go over to our app. Obviously, you probably go on your calculator. Alright. So I pushed the y equals button right here. Well, I can't circle it, but let's type in what it was. So remember, one line has to have the positive and one has to have negative. So we're going to have square root of, this is the positive one, so we have 3 plus x. Never used this before, actually, so then we have plus 2, and then 3 minus x minus 2. Oh, I forgot to do the squared on that. Oh, dumb. That's what's dumb about the TI-84s, because they always erase the whole thing. I don't even know how. Okay. Any day now. Alright, we need to do squared. Does that work? Okay. Minus x minus 2 squared. It takes longer on this thing, of course. Now I'll just move over so that's not there. Then minus 3. That's the positive one. Now we need to have the negative one. Negative square root, since we had plus or minus. And then you just type in the same thing for that. Squared. 3 minus x minus 2. Then, hey, I don't want that to be. I'll just say minus 0 so I don't have to redo this thing. Don't get confused by that. I just did that so I wouldn't have to clear the whole thing. Okay, now we want a graph. Let's see. That's not right. It's definitely not right. Must have done something wrong. On this thing, you can... Okay, no, you can't. Well, so much for this video showing how to do that in the calculator. I know I did something wrong, but you see the process of what you're supposed to do. I did have a equation I already tried out in the calculator to see, and if it would work. Let's since that didn't seem to work. Oh, what the heck? No wonder I had squares on there. That I wasn't supposed to. That's your answer right there, because that cancels out the square root. That's why. So sorry. No squares. Didn't mean to do that. All right. So there we go. Found our problem. I need to delete that. Okay. Go back on there. Wish I could not. Alright, just skip the video ahead so you don't have to see me type this thing again. No squared. Oh, cosine, great. Ugh, hate this thing. X plus 2. Alright, that's the positive one. Now the negative one, finally. Plus x plus 2. Tan. Oh my gosh. I need to watch where I'm tapping. X minus 2. Oh, great. I forgot our k's. At least I can do that easily. I typed a plus. Let's see, maybe it will not recognize that or something. Yep, it said Y2 is bad, so that's why I didn't do it. There we go. Gotta type this stupid thing again. Okay. I really apologize for this not so good video. Okay, cosine. Okay. Oh my gosh, I can't believe how long this thing's taking. Sometimes technology just makes me mad. You know, why don't you comment below if you somehow know how to not clear the whole thing? I mean, I've tried to figure that out for such a long time, and it's really been annoying. And then I left off the negative there, didn't I? Okay, there's a lot of things I could say, but not on Jacob Nash. I'll leave it at that. This is the worst technology thing I've done. Finally. Now, that doesn't really look exactly like a circle. That looks more like an ellipse. That may have just been the way that it's turned out. I don't understand why that's like that, but I'm not going to do anything else with TI-84, because I know on Desmos it wouldn't do that, so I don't know what's wrong with it. So that will be it for this long video. I don't know how long it was, but I imagine it was a technology issue. So that's it for this video, and I'll see you on the next one. Thanks for watching.